in this video we want to talk about proportions. So proportions are how you look at two ratios and decide if they're equivalent, and equivalent just means equal. So proportion is what you use to determine if two ratios are equivalent. So we're going to use a proportion. So we would want to set up two fractions or two ratios and determine if they're equivalent. So to do this, we're going to cross multiply, and that means we're going to use the denominator of one fraction or ratio and multiply it by the denominator of another. So we would multiply this way. You'll often see this spacey looking bubble like this. So I would want to multiply 1 times 4 and 2 times 2. And both of these would be 4. So in this case, we would know that this proportion is equivalent, because we did 1 times 4 and 2 times 2. We're cross multiplying. Makes this big X. We can use the same method to solve for a missing piece of this proportion. So let's say that this 4 hadn't been here, and instead it had been an X. We could have done this and cross multiplied and solved using a type of equation. So let's look at something like that. So in this case, we want to cross multiply and solve. So if I cross multiply here, I'm going to get 10 times n, or 10n. If I cross multiply here, I get 6 times 5, or 10n equals 30. So now I have a one-step equation, which we know how to solve. So to find out what n equals, I would divide both sides by 10, and I learned that n is going to equal 3. And if I plugged that back in to my original proportion, I would find that 3 over 5 is equal to 6 over 10. And if I look at that, I've got two equivalent fractions, and I know that if I do 3 times 2, I get 6, and 5 times 2, I get 10. So indeed, those are equivalent ratios, or equivalent fractions. So what about this one? If I cross multiply, I get 15x. Cross multiply here, 7 times 30, that is 210. So if I divide both sides by 15, I'm certainly getting a number larger than 2. Did I multiply that wrong? So I would take 15 into 210. 15 goes into 21 one time. Minus 15, we're going to get 6. Bring down the 0, we're going to get 14. So I would get 14/30ths, which makes sense. X equals 14. Alright, what about this one? 12 times 5, that's going to give me 60 on one side. 9x, whoops. I'm going to get 9x on this side. So when I divide both sides by 9, 9 goes into 60. This time it doesn't come out quite so evenly. 9 goes into 60. Let's see. We know that 9 times 6 gives us 54. Maybe with 6. Which is going to give you 9 and 6/9, or not 6 and 2/3. So you're going to get a decimal of 6.6 repeating. So this time your x equals 6.6 repeating. There's no reason why you can't have a fraction, so 6 and 2/3. And of course, 9/12 over here equals 3/4. So that is how you solve a proportion. Every time you want to cross multiply so that you get something times a variable, and then you divide to isolate your variable. So solving proportions is very simple. You want to set up a ratio of, or get two equivalent fractions, and then you simply want to solve until you have a variable standing all by itself. proportions.